In this video, we're going to learn a different method for finding the inverse of a 2 by 2 matrix. And this method can be used on any size square matrix to find its inverse. So let's take a look at the two examples we did in the last video. We've got matrix B and matrix C. How can we find the inverse of a 2 by 2 matrix without using the determinant? Well, let's go ahead and write the matrix. We're going to expand the matrix slightly. We are going to add to the right-hand side of the matrix the identity matrix for a 2 by 2 matrix. And remember, the identity matrix is a matrix that has all ones along the diagonal and zeros everywhere else. So we doubled the size of our matrix. The next thing that we're going to do is, our whole goal with using this matrix is to transform it into a matrix where the identity matrix is on the opposite side. And then you have these 4 slots filled with some number. This resulting 2 by 2 matrix will be the inverse matrix if it exists. So let's go ahead and use this right here in our example. So the first thing we have to do is we're going to do exactly the same thing that we did when we were solving matrix equations. We are going to eliminate this first. So how would we eliminate this? We would go ahead and multiply this bottom row by a -3, and then we would add these 2 rows together. So let's go ahead and do the math off to the side. We have a -3, 6, 1, 0 in this first row. Let's multiply the second row by a -3, and we get a +3, a -9, a 0, and a -3. When we add those, we get 0, -3, 1, -3. We're going to go ahead and replace, since we were trying to eliminate this -1, we're going to replace the bottom row with our new row. And our new matrix now looks like this. As with equations, the next thing that we're going to try and eliminate is this 6. So it looks like what we need to do is we need to multiply our bottom row by a +2 and then go ahead and add. So let's go ahead and do our math over here. We're going to take our -3, 6, 1, 0. We'll multiply this bottom row by 2, 0, -6, 2, -6, and we'll go ahead and add to get this. And because we are trying to eliminate this top 6 over here, we're going to replace our very first row with our new row. And we get a -3, 0, 3, -6. 0, -3, 1, -3. The last thing that we need to do, just like when we were solving matrices, is we need to make sure all of the numbers in our diagonal are 1. So now we're going to divide the first row by a -3 and the second row by a -3. And when we're done, we get a 1, a 0, a -1, and a 2. On the bottom row, we get a 0, a 1, a -1/3, and a +1. And as I said in my introduction here, that the resulting 2 by 2 matrix over here is the inverse matrix. And there we go. We have the identity matrix now on the left instead of on the right, and we have the inverse matrix here on the right. So the inverse of matrix B equals -1, 2, -1/3, and 1.